This is basically the table which shows us the concept of voltage rise and voltage drop, and for it we should always have the polarity across all our elements. When it comes to the voltage sources, the polarity is already defined because all the DC voltage sources have negative terminal, positive terminal. But what about the passive elements? Just like here, the resistor doesn't have the predefined polarity, so in finding out the current value of current or value of the voltage across it, we have to give it the polarity which is according to the rules defined here, and these are the theoretical rules. So when we can see here that for this circuit here, the current is entering through the negative elements and it is leaving the positive elements. So here the voltage is the this voltage is the voltage rise, which is V of S. Similarly, for the passive elements, we have seen here that for across the passive elements we always have the voltage drop, and for the voltage drop we developed a rule in which the current always enters through positive and leaves through the negative. So therefore it is the for our defined direction of the current is entering through this terminal and leaving through this one. This is the passive element, so that's why the polarity here is positive and negative, and this is again the voltage drop, and it is denoted by V of R. Okay, so I think it is clear now that how to define the polarities of the passive elements, because for the active elements it is already defined, and here in this scenario the voltage across the active element is rising voltage. So putting our values here, this is V of S, and V of S, the value of V of R is I of R into R, or we have to find out the value of I of R, and I of R is V of S divided by R. Value of putting the values here, this is 10 volts, this is 1 ohm, so this is Ohm's law. According to Ohm's law, the value of current is 10 amps. Okay, so this is the value which we have calculated for our clockwise direction. Similarly, let us consider another scenario. Let me remove all these. Okay, this is the resistor. Okay, let us consider again another direction of the current, and this direction is basically the counterclockwise, and let me write it here. This is scenario number 1. Scenario number 2, the value is counterclockwise direction. Okay, wrong direction. This is the counterclockwise direction. So again, now here we can see the values here. Again, this is the passive element, and I have told you by changing the direction of the current, the polarity of this theoretical polarity of our resistor will also change, because for our resistor is the passive element, and across passive element we always have the voltage drop, which we have shown in this table. Okay, so what happens here is that the for the passive elements, the current always enters positive and leaves negative. Therefore when it enters the positive and leaves through negative elements, so it is the voltage drop, and it can be written here at this location. Okay, we are using equation number 1 here again, and according to this equation, VR is at the right end, which is for the voltage drop. Similarly, when currents enter, again we can see that by changing the direction of the current, now here for the source current is entering through positive elements and leaving through negative elements. So what is the concept here? This is a source, active elements, so how come it drops voltage? According to our developed rules, we can see here that for the passive or active or passive elements, both can drop the voltage. Across both of the elements we can have the voltage drop. So voltage drop here, and this is again V of S, because it is the sum of all voltage drops. So we had 2 elements in our circuit, therefore at the left end we will have 0. Okay, so this is the equation for now this circuit where we have changed the direction of the current, which is IR prime. It was IR here, now here IR prime. By allocating the variables here, we can have Vs equal to minus VR, or by changing the values here, or by writing the values here, we will have minus IR prime multiplied by R, or the value of IR prime here is minus V of S by R. Putting the values here, we will get this is 10 volts and this is basically 1 ohm. So now the value will be minus 10 amps instead of the positive 10 amps. So what is the concept here? How come it changes to negative, and what is meant by this negative sign, and what is meant by this positive sign? So actually positive sign shows us that the direction which we have considered, which was clockwise, when it was positive 10 ampere, it was correct, while when we considered it is the counterclockwise, it is negative 10 amperes, and the negative sign shows us that the considered direction of the current is opposite that of the actual current direction. So this is the overall concept. Thank you so much, and I'll see you.